Question 16. Three resistors are connected in series to an 8-volt ideal battery, as shown in the diagram. The resistors have resistances of 100 ohms, 220 ohms, and 180 ohms. What is the potential difference across the 220 ohm resistor? This question tests our understanding of series circuits and how voltage divides across resistors. So what do we know? In a series circuit, the same current flows through every resistor. This means the current through each resistor is identical, no matter the individual resistance values. The total resistance in a series circuit is the sum of all individual resistances. Therefore, we can calculate the total resistance by simply adding the resistances of the three resistors. The supply voltage from the battery divides across the resistors in proportion to their resistances. That is, a resistor with higher resistance will have a larger share of the total voltage. Let's brainstorm for the solution. First, we calculate the total resistance. Total resistance equals the sum of all resistances. 100 ohms plus 220 ohms plus 180 ohms. Adding these together gives a total resistance of 500 ohms. Next, we calculate the current in the circuit. Using Ohm's law, current equals the total voltage divided by the total resistance. Substituting in the values, current equals 8 volts divided by 500 ohms. This gives a current of 0.016 amperes. With the current known, we can find the potential difference across the 220 ohm resistor. The voltage across a resistor in series is the current multiplied by the resistance, so voltage equals 0.016 amperes multiplied by 220 ohms. This gives a voltage of 3.52 volts, which we can approximate as 3.5 volts. This is our final answer. What did we do? We calculated the total resistance by adding all series resistances, then we found the current using Ohm's law applied to the total circuit, and finally, we calculated the voltage across the specific resistor using the current multiplied by its resistance. Let's see a tip that provides an alternative way to solve the problem. An alternative approach to find the voltage across a series resistor is to use the resistance ratio. Since the voltage is shared among the resistors in proportion to their resistances, it follows that the voltage of each resistor equals its resistance as a fraction of the total times the total voltage. Hence, the voltage across the 220 ohm resistor equals its resistance of 220 ohms, divided by the sum of all the resistances and multiplied by the total voltage of 8 volts. This gives the same potential difference as we already got. Job done. In summary, here are the key points for this problem. In series circuits, all components share the same current. We add the resistances directly to get the total resistance. Ohm's law applies both to the whole circuit and to individual resistors. The voltage across a resistor can alternatively be found using the resistance ratio compared to the total resistance, multiplied by the total voltage.